Hi, I'm Patrick Price, a Senior Applications Engineer at Stratasys, and I'll be describing the benefits of using FDM technology and materials for drill guides, and we'll also go through the basics of how to design them. Many parts that are produced through various manufacturing methods require holes to be drilled in them after production. Drilling and locating holes individually can be extremely time-consuming and less accurate than using a jig to aid in this process. Machining these drill guides out of metal can lead to wasted materials, long lead times, and heavy tools. FDM technology is a good fit for drill guides because it makes it easy to produce complex, lightweight, and ergonomic shapes. The range of FDM materials available cover the many possible needs for these tools, like stiffness and chemical resistance. Being made from thermoplastics also allows for hardened drill bushings to either be press-fit or heat-staked into the tool, ultimately increasing longevity. Pairing these benefits with the accuracy and repeatability of Stratasys 3D printers makes for a great application. FDM drill guides demonstrate the highest benefit when the surface needing to be drilled is complex. Here are a few examples that demonstrate where additive shows a significant benefit. This ASA drill guide is used to create the mounting holes for the wing lighting of a small aircraft. The part was designed to locate all the holes at once by wrapping around the profile of the wingtip. This optimized locating design uses very little material when produced through FDM, but will require a large amount of material for machining. The guide incorporates an ergonomic handle into the design for ease of use and allows the operator to easily hold the guide in place while drilling. The other example is a drill guide that is used to drill holes in a carbon fiber panel. The guide has a slight curve to it to match the curve of the panel. The features of the guide match those of the panel in the critical areas to prevent movement during the drilling process. The part was made from Nylon 12 CF to provide a stiff drill guide that would not deflect and has hardened drill bushings pressed into it for increased durability of the tool. Material usage was reduced through eliminating areas that were not crucial to either the locating or the drilling process. Drill guides can be produced on various Stratasys FDM systems and out of the many FDM material offerings. The F123 series is great for small, low-requirement drill guides, and the stiffness of the ABS CF10 material can be utilized. The F770 allows for much larger single-piece drill guides out of ABS or ASA due to its big build volume. Stratasys also offers advanced materials that meet the demands of high-requirement drill guides such as Nylon 12 CF for even greater stiffness, Ultem 9085 resin for improved strength, and the Antero PEC-based material for superior chemical resistance. To create a drill guide, first we will start with the part that is being drilled and either offset and thicken the surface that our drill guide will interact with, or make a sketch on a plane above and extrude to this surface. Unnecessary material can be eliminated to reduce the weight and material usage. At this point, ergonomic handles and additional locating features can be added. If using hardened drill bushings, which is recommended, the holes will need to be resized to account for these bushings. Refer to the manufacturer's guidelines for the interference to use when press fitting or heat staking and adjust the hole size accordingly. This step can also be done within the GrabCAD Print app using the Apply Insert feature under the Model Settings tab and then using the Custom Hole Size tool. The design and production of drill guides using FDM is a straightforward process with significant benefits. For more information about this application or other 3D printing manufacturing solutions, contact your Stratasys representative or visit stratasys.com. Thank you for watching.